Magnets are made from alloy of iron, cobalt and nickel. Nepermuk, an alloy of iron, nickel, aluminium and titanium is used to make magnets. Let's discuss two experiments now under the point magnetism. You can see it on the textbook page number 126. In the first part, we see that there is one steel bar, one steel bar and a magnet, a bar magnet with two independent poles. One is north pole and the other one is the south pole. A north pole is rubbed on the steel bar, dragging from point A to point B. Again, lift up the bar magnet and rub it on the steel bar from A to B. In the same direction, go it again and again, at least 15 to 20 times. This method of magnetism is called the single touch method. What do we observe under this experiment, under this method? We will see that the steel bar will be magnetized. It will be somewhat magnetized. Magnetized means it will do the work of magnet. It will get attracted towards the magnetic materials. In the second method, to the right side of the same page, page number 126, there are two magnets taken, one with north pole rubbed on the bar, steel bar, and the another one with south pole rubbed on the steel bar. This method of magnetism is called the double touch method. Why single touch and why double touch? Because in the first case we rub only one magnet and in the second case we rub two magnets. So therefore single touch and double touch method. In both the methods we observe that the bar, the steel bar will attract towards the magnetic objects. It will behave like a magnet. But in single touch method the steel bar will remain for a short period of time behaving like a magnet as compared to the second one. In the second one we do the process by double touch method. Yes, so the magnetic power which is occupied, which is concentrated into the steel bar due to the rubbing of magnets, that will remain for little longer period of time. Our next point is Earth, a gigantic magnet. We are standing on the surface of the Earth, right? Earth has which force? It has the gravitational force concentrated to the center of it. And we are able to stand on the surface of the Earth since there is a kind of magnetic power present into the Earth. Therefore, we are able to stand. If there would be no magnetic power in the Earth, we would not be able to stand, we would not be able to sit. No object would remain on the surface of the Earth. The scientist William Gilbert gave a scientific explanation based on experiment of the observation that a freely suspended magnet always settles in a north-south direction. The north pole of a freely suspended magnet settles in the direction of geographic north pole of the Earth. This happens when a magnet is freely suspended. When a magnet is freely suspended, the north pole and the south pole gets settled down to the geographic north pole and the south pole of the Earth. What if it is not freely suspended? That means if there are magnets on the Earth and if they are not freely suspended, that time sometimes it can happen like the north pole of the magnet can settle to the south pole of the Earth, or the south pole of the magnet can settle to the north pole of the Earth when it is not freely suspended, if it is kept simply on the surface of the Earth, on the Earth. Magnetic needle. If we take a magnetic needle, tuck it to the cardboard and place the piece of that cardboard into the bowl of water which has all the directions on it, west, south, east and north, we will observe that the magnetic needle will get diverted, will settle down in the places of north-south direction of the geographic system of Earth. Magnetic field. The magnet attracts the needles from afar. In other words, the magnet has an effect even at a distance. You can easily experience it if you take a simple magnet, any kind of magnet, and you keep some iron fillings or some needles or some pins. When they are at a certain distance, still they will get attracted towards the magnet. You don't have to personally place the magnet close, very close, or towards the pins. If they are at a certain distance, then too they will get attracted. A British researcher named Michael Faraday, when he took a magnet, a bar magnet, and some iron fillings, when he sprinkled all the iron fillings on a piece of paper or a table, and he kept the bar magnet at center of the table with iron fillings on it. With a gentle tap on the piece of paper or a table, he saw that there is a formation of circular like lines. Those lines were called as magnetic lines of force. How are they seen to be? They are seen to be that the magnetic force is concentrated to the two poles of the magnet, that is the south pole and the north pole. It is not towards the center of the magnet. Also, we can see that the lines of the force, the magnetic lines of force, are in the circular path such that their concentration is towards the poles of the magnet. The region around a magnet where the magnetic force acts on an object is a magnetic field. The intensity of a magnetic field is low where the lines of force are spare, and the intensity is high where the lines of force are concentrated. Spare means where they are little bit far away. Okay, that spare lines can be seen near the center of the magnet, and near the concentrated area, that is the poles, they are high. The intensity is high. Properties of magnetic lines of force. Here are some properties of magnetic lines of force. Magnetic lines of force are imaginary connecting lines, and Faraday introduced the concept of lines of force in order to explain magnetic attraction and repulsion. Magnetic lines of force always run from the north pole to the south pole. The south pole may be of the same magnet or a different one. Magnetic lines of force are in the state of tension like a stretched spring. Magnetic lines of force repel each other. Magnetic lines of force do not intersect each other. The number of magnetic lines force are at a particular point determines the strength of the magnetic field there. Penetrating ability of magnetic field. In the first experiment, we see that there is a cardboard with some pins below the cardboard, and there is one bar magnet above the cardboard. If you do this experiment, you will observe that the magnetic force of attraction passes or penetrates through a soft object, through a light or a thin object. Cardboard is very thin, so magnetic force passes through the cardboard and the pins are getting attracted towards the magnet. If you increase the layers of the cardboard, we will see that the magnetic force decreases slowly, not even with just 2 or 3 cardboards, but if there are 10, 15 cardboards, 12 cardboards, 8 cardboards, the concentration or the magnetic force will get reduced. It does not pass that much as compared to which passes through a single layer of cardboard. Magnetic field can pass through a cardboard, a bottle or water. However, in each case, the intensity of magnetic field is found to decrease. Metal detectors. Metal detectors are used to detect the metals. Simple and easy way to explain, to detect a particular metal, that is the metal detector. This work is done by electromagnets. They are used in very important places like airports, bus stations, certain temples, and buildings. They are used for inspection of person entering these places. Metal detectors are used to detect very precious articles and also in the food processing industries to detect any iron steel object mixed unknowingly in foodstuffs as this would be harmful to health. In geology, these machines are used to detect the presence and quality of metals. Thank you.